A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and it was cats a couple of weeks ago. Now it's birds that start the program. You're listening to Space Nuts. My name's Andrew Dunkley, and joining me, as always, is Fred Watson from the Australian Astronomical Observatory. Hello, Fred. You've got a gaggle of geese and a plethora of feathered friends.
Plovers, yeah.
Yeah, plovers. Oh, yeah. They can be nasty little critters, the plovers.
Yeah, no, there's it's a very rural environment that I live in. So
yeah, it's nice.
Lots of things going on.
Nice. How are you, Fred?
I'm very well, thank you, Andrew. How are you?
I am quite well, thank you very much for asking. Now, today we are going to talk about this latest Mars mission, which has just lifted off from California for the first time ever for an interplanetary visit. They're going up there to look at quakes and analyse the internal geology of the red planet, which is very exciting because we can learn a lot from that. New research into a phenomenon that is known as Steve, which involves the northern and southern lights. And we'll tell you why it's called Steve if you don't already know. But if you've got young children and they watch children's movies, you probably already have figured this one out. And a question from Paul in Victoria, Australia, not Victoria, Canada, or Victoria in South Africa, or wherever there are other Victorias. This is our Victoria, about star mapping. To keep it simple, it's a bit more complicated than that. But first, Fred, this latest mission to Mars, the Mars InSight lander, is on its way.
It is, absolutely. As we speak, it has taken flight, which it did earlier this week, on its way to Mars, a journey that will end on, I think it's the 26th or thereabouts of November, when the InSight lander does what its name suggests and lands on Mars. InSight is a spacecraft that's almost like a recycled NASA spacecraft because it's based on the Phoenix design. Phoenix, I'm sure you and I talked about it back in 2008 when it did its thing in the northern Arctic region of Mars. Phoenix was a lander that basically didn't have any wheels. It just landed, had a backhoe scoop on it that dug up the soil of Mars so people could have a look, and sure enough, they found lots and lots of water, ice underneath the surface soil. So InSight is based on the same chassis, as it were, which in technical terms is called a bus. The bus is the framework of the spacecraft. But InSight, once again, it doesn't have any wheels. It won't go anywhere. But it's designed with a different purpose in mind. In fact, the name is a pretty contrived, I think, acronym, which starts with, the acronym is Interior Exploration Using Seismic Investigations, Geodesy and Heat Transport. And if you put all that together and mix it up, it spells InSight. It will land on it's actually now in the equatorial part of Mars, and in a way, the first two letters of the acronym, or the first two words, tell you what it's about. Interior exploration. It's about looking at the internal structure of Mars, about which we don't know that much. We do know that Mars differs from the Earth in not having tectonic plates plate activity, unlike the Earth, which has continents drifting around all over the place. Mars
well,
doesn't.
we're seeing a lot of that activity now, and if you're in Hawaii, hello.
Yes, that's
good
right.
grief.
Yeah,
that's been
exactly.
quite amazing. But yeah, that's tectonic activity, definitely, or volcanic activity. But Mars doesn't have that. In fact, we up until recently, we considered it to be something of a dead planet. So this will certainly give us an insight into whether or not that's the truth.
That's right. And actually, in many ways, there's a parallel there from what you've just mentioned about Hawaii. So the Hawaiian volcanoes don't sit on a plate boundary. They are in the middle of the Pacific crustal plate. But what drives them is a magma hotspot. In other words, there's molten magma not very far below the surface that pokes through, and it's actually as the Pacific plate has drifted across that hotspot, we've got this chain of volcanoes which have formed the Hawaiian Islands. Now Mars has something similar, because Mars has the biggest volcano in the solar system,
Olympus Mons.
That's the one. Yeah. How high is it? Do you remember?
It's massively high.
I
can't remember.
27 kilometers.
I was going to say 26, but I knew it was in the 20s. But and in terms of broad landscape, it's it's just huge. If you walk from one end of it to the other, it's
hundreds of kilometers.
Yeah.
But the reason why Olympus Mons has grown so big, and actually there are 2 or 3 other volcanoes not very far away, is because there isn't the plate tectonic activity. So the crust is not drifting over the hotspot. There's a magma hotspot underneath, which basically just kept on pouring out stuff through these craters, and basically built up this very, very high shield volcano. Shield volcano is one that's rather flat in structure, like the Hawaiian ones are.
Yes.
But Olympus Mons grew very tall. So that we know the geology is interesting on Mars, but we don't really know much about the internal structure. Like, is there an iron core? Is that iron core divided into a solid and liquid core like the Earth's is? That seems unlikely, in fact, because Mars has very little magnetic field, and we know that the Earth's magnetic field comes from the iron core. But then questions about the mantle of soft rock which overlays the core on the Earth, and we presume something similar happens on Mars with a crust over the top of that. Now, the way we find out about the internal structure of the Earth fundamentally is to use seismology, to use the effect of earthquakes, the vibrations of earthquakes being transmitted through the bulk of Mars. Through the bulk of the Earth. So we know that as an earthquake occurs, perhaps at one of these plate tectonic boundaries, the vibrations from that are transmitted through the Earth, and they are transmitted in different ways depending on what they're traveling through, and they actually get refracted at boundaries, a bit like light waves are refracted by a glass surface. And it's by picking up those seismic vibrations that you can tell what the internal structure of the Earth is. So we don't have many earthquakes on Mars, or Marsquakes, I guess you'd call them. But what we do have on Mars, because the atmosphere is thinner than it is on Earth, is a bigger bombardment of meteorites. So meteorites hit Mars's surface. Some of them are quite big. They're big enough to cause seismic waves. And the idea is that InSight will pick these up, and by doing that, we'll be able to analyze the internal structure of the planet, at least to a degree that will give us more idea of what's going on than we have now.
Okay. So we're relying on impacts that are likely to occur after InSight has landed and it's sitting there going, okay, ready, hit me.
Yeah, more or less, yeah.
Have we calculated a time frame where more of that is likely to occur, or are we just playing dumb luck here?
Yeah, I think with meteorites, these are what you might call sporadic meteorites. They're not anything linked, for example, with what we would call meteor showers on Earth, although Mars does get those as well. The project lasts for about 2 years, and the scientists figure that's long enough to actually get the sort of data that they want, which basically, in the last analysis should give us a good 3D image of what the internal part of the planet looks like. There's three separate experiments. There's the seismometers themselves. There's also a radio system that is almost like a GPS, because there are spacecraft in orbit around Mars, and that radio system will give you a very accurate position of where the spacecraft is in relation to the pole of Mars. Now, we know, like the Earth, the pole of Mars, the rotational pole, wanders a bit, just like the Earth's does. And it's that wandering that gives you some idea of what's going on inside the planet. So the wobbles in the rotation of Mars, they're tiny, but they do exist, will also feed into our understanding of the internal composition of Mars. And then the other one is what's called a self-hammering probe. It's a probe that basically will burrow 5 meters into the soil of Mars, and we'll look at heat transport from the interior. It's basically clever thermometry that they're doing,
if any.
So, yeah, that's right. So very, very interesting set of experiments that are very carefully designed to give us this information. So the region where it will land, the hope is that it's a region that's pretty smooth. It's not got many big dangerous rocks, and it is in fact the 26th of November when it will come down.
I was going to ask you how long it takes, and that's the reason they lifted off from California, isn't it? Because it actually reduced the travel time to a certain degree.
Yeah, I think it also reduced the wait time to get a launch window, because there are fewer. There's a shorter queue at the launch site in California, Vandenberg launch site. So we will follow InSight with interest and hope to gain some insights.
It could be exciting, or it could be a dead loss. We don't know yet. We'll just have to wait and see. And
everything we do is exciting.
Of course it is. Yeah, I mean, going to Mars full stop is exciting. I love the place. Yeah. All right. Well, we'll certainly report back on InSight in the months to come on Space Nuts with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now we're going to revisit something we discussed, must have been last year, might have been more recent, I don't know, we can't keep up with ourselves, called Steve. Steve is a phenomenon involving the northern and southern lights, and some new research has now been released into this phenomenon known as Steve. Fred, I suppose we should start by explaining why this is called Steve and how you astronomy people have messed it all up.
Yeah. Well, you're quite right. It really is an interesting story, this, because when we think about things like the northern and southern lights, they've been well observed for thousands of years, and people understand the structures. We've known how they work for a bit more than 100 years. They're caused by subatomic particles coming from the sun. And so in many ways, it's a bit of a surprise that a new type of aurora has only just been observed and noted. And unlike the sort of greenish curtains of light that we've all seen pictures of the aurora, and some of us have seen them firsthand, those greenish and
you lucky duck.
I wasn't going to say that. Some of the greenish and pinkish curtains of light that you see, they're very characteristic. They've got a particular shape, but this one, the Steve, is quite different. First of all, it tends to be purple in colour, and it's a very narrow ribbon of light across the sky. It runs across the whole sky, this narrow purplish ribbon, and they started. They basically, people started talking about them probably 5-10 years ago. And eventually it bubbled to the surface of what you might call citizen science, ordinary people looking at the sky and trying to work out what's going on. And people figured they needed a name for it. And the reason why it was called Steve is because there is a movie called Over the Hedge. I think it's a Pixar movie, if I remember rightly. I haven't seen it myself. Yes. In which some of the characters, it's a kid's movie, some of the characters see a creature that they've never seen before, and because they don't know what it is, they need a name and they call it Steve. So Steve is the gift to things when you don't know what they are.
Yeah.
And
okay, so that's
how
that,
it worked.
and that's been based on the premise in the movie that this unknown thing became Steve just for the sake of giving it a name. So that's why this is called Steve, because they don't know what it is. But now they've messed it up, haven't
Well, yeah, it's...
I mean, this is just a sideline.
It is a sideline to the story.
Strong
but
thermal emission velocity enhancement. It's been post-named.
It's not messing it up at all.
Come on. It's horrible.
Let me get to the academic side of this, because what's now happened is, of course, the citizen science work has alerted atmospheric scientists and people who deal in auroras to essentially to study this in detail. And there has now been a paper published in Science, the prestigious American science journal. The paper is called New Science in Plain Sight. Citizen scientists lead to the discovery of optical structure in the upper atmosphere. Now, that's putting the Steve in the most fancy terms. It's by Elizabeth MacDonald and her colleagues, based at various institutions in the US and elsewhere. But the abstract for the paper describes the phenomenon very, very well. A glowing ribbon of purple light running east-west in the night sky has recently been observed by citizen scientists. This narrow subaural visible structure, distinct from the traditional auroral oval, was largely undocumented in the scientific literature, and little was known about its formation. And then they go on to say that, photo sequences taken by amateurs show the distinct colours, and there's a whole lot of blur. But then at the end of the abstract, it says, on the basis of the measured ion properties and original citizen science name, we propose to identify this arc as a strong thermal emission velocity enhancement, or Steve.
Somebody had too much time and a very big thesaurus.
I think they've done very well. I think it's a name that actually describes the phenomenon very, very well, and I think that kind of reverse engineering has been very nicely done. Actually, when we spoke about it last, Andrew, they were already suggesting that name as a possibility. So it's now enshrined in the scientific literature. And the other reason why it's been in the news, not just because this paper was published about a month ago, a month and a half ago, it's also been in the news because there have been some interesting observations of Steve's seen during in North America. It's actually ventured further south than it normally does. It seems to occupy a broader latitude band than the traditional auroras, and that's because its origin is slightly different. It's all about high velocity plasma flows in the upper atmosphere being excited to glow. It's not so much about the bombardment of the Earth by the solar particles, which is certainly what causes the normal aurora. But the fact that it's got a different origin means that you can see it in different latitude regions away from the poles. So here in Australia, we should be looking out for Steve's. And I think I'm right in saying, I'm sure some of our listeners might prove me wrong, but I think I'm right in saying that we have not yet had observations of a Steve reported in actually possibly even in the southern hemisphere. I haven't seen anything that's reported them in the southern hemisphere. That might just be me missing something.
Well, but there's a lot more isolation in this part of the hemisphere
exactly
as well, in this part of the planet. So it's every possibility we just haven't seen them. And I guess it stands to reason that this is not new. These have probably been going for as long as Aurora, but we've only just noticed them. Is that fair point?
I think that is correct. I mean, on the other side of the coin there, for the last 50 years, there have been permanent auroral observatories. I've visited some of them in northern Scandinavia, which have all sky images of the sky every night, sometimes for every minute of every night, to record the aurora. And these things have not been noticed. They maybe don't show up very well on an all-sky camera because they are narrow. They're only 25 kilometers wide, and they're something like 400 kilometers high. So they are a really narrow ribbon of light. I'd love to see one, Andrew, and you can be sure you'll be the first to hear about it if I do.
Yes, indeed. In fact, I'm looking at a photograph of one that's on the Space Weather website, and you could actually be mistaken for thinking it's just a glitch in the photography.
Yes,
you often see that kind of light in a photograph where the sun has hit at the wrong angle and causes a little streak. That's what it looks like. I'm also trying to figure out what the people are watching on TV in that house that's in the photo. But it's quite it's a very beautiful phenomenon. That's I think just like the aurora australis and the aurora borealis, it is quite stunning. So to see it for real would be amazing.
I think so. The fact that we now know about this it is going to alert people to look for it, and we're sure to find more observations of it, and hopefully some in the southern hemisphere.
Hopefully over my place. That'd be nice.
They don't come to Dubbo. No.
Yeah, but if anyone does see one, and if they do photograph something extraordinary like Hannah did for us, or she did for herself, but she sent us the photo of those noctilucent clouds the other day. Yes, let us know. We'd certainly love to find out about your observations, and we will wait with bated breath, Fred. This is Space Nuts, and great to have your company on episode 102.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we're going to bump off one of our handful of questions. Actually, we've got more than a handful at the moment, so I'm thinking maybe in a future episode in the next few weeks we could bump off a whole bunch in one big session. See if we can do that. Maybe get up to date. That'd be nice. But we're going to just tackle the one question for now. Hi, Fred and Andrew. I love the show and listen to every episode. And he put one more exclamation mark than Hannah did. I have a question. When scientists map our galaxy, do they try to describe where the stars appear at the moment they are mapped, or do they account for time changing the position where they appear to be? Thanks and love the show. Cheers, Paul Batty, Vermont, Victoria. Good question. Don't know.
What do you reckon the answer is, Andrew?
I think they'd have to account for some kind of shift, wouldn't they?
Yeah, we do. That's absolutely right. And in fact,
thank you for the question, Paul, and we'll see you next week.
This is a... Don't go away, Paul. Hang on. He hasn't finished yet.
No.
This is a question that's really quite newsworthy at the moment because there is a spacecraft in orbit called Gaia, and Gaia is tasked with mapping the stars in our galaxy, or the local stars in our galaxy, to an accuracy that has never been done before. A very, very hyper-accurate map of these positions. They're talking about millionths of an arc-second. And 1 arc-second is 1/3600th of a degree. It's a tiny angle. So a millionth is an even tinier one. Now, that's one of the reasons for doing that is, well, first of all, to know where the stars are, but more especially to do what is the subplot of Paul's question, and that is to work out the motions of these stars. So if you can map the stars in the sky with this amazing accuracy, and then do it again a couple of years later, what you see is a slightly different map because the stars all move, and so they move with what we call it a proper motion. That's the technical name for the motion of a star across the sky. It's not the true motion of the star, because that includes what we call a radial component, backwards and forwards. But we at the Australian Astronomical Observatory are currently running a large survey project which will actually give us that radial component, what we call the radial velocity, the backwards and forwards component of the velocity. But what you might call the transverse component, the motion of a star across the sky, aka its proper motion, that is what is detected by a system like Gaia, taking 2 lots of observations. In the olden days, what we used to do was take photographs of the sky from the ground, of course, and then wait 20 years and then take another one of the same bit of sky, and that would allow you then to calculate these proper motions. But now, because of this exquisite precision of the Gaia spacecraft, we can do it in a much shorter time span. So Paul's absolutely right. When we map the galaxy, we don't just map their present position, we also map the motion of these stars, so that, for example, if you wanted to get accurate positions of stars 20 years down the track, you can kind of fast forward because you know what their motion is, you know how they're moving. The other thing that comes from all this is a better understanding of the dynamics of our galaxy. That's the way to swirl around the center of our galaxy. By working out these motions, we can establish all kinds of interesting aspects of the gravitational potential of the galaxy. Things like finding stars that belong to the same groups as one another, which probably mean they've come from the same gas cloud. Maybe one day we'll even use this technique to find the siblings of the sun, which we know the sun would have, because it was formed in a gas cloud, not a glass cloud, a gas cloud with other stars, whose identity we don't know at present. So all that, the things that are behind Paul's question feed into the very best contemporary science in understanding our galaxy. So a great question.
Fabulous. Thank you, Paul. And we certainly encourage questions, maybe not for another couple of years because we've got so many to catch up on. But, hey, we'll do our best for you. But, thank you, Paul. That's great. And, good answer, Fred. Well done. You should be an astronomer. Now, before we go, I do want to make one more point without notice. This week is marked the 50th anniversary of an historical, almost disastrous event. With a test flight by Neil Armstrong of the Lunar Landing Research Vehicle. And you were talking earlier about the bus, which is the apparatus that a probe lands on. This was like a bus, a rocket-propelled apparatus designed to sort of practice a lunar landing. This happened at Ellington Air Force Base near Houston. Apparently there was a fuel leak and he lost flight control, and he had to eject from the aircraft. And the only injury to Neil Armstrong 50 years ago on, I think it was the 6th of May, was that he bit his tongue. And there's a very funny sideline to this story, and that is that the word got through to some important people about an hour after the event, and one of them went and found Neil Armstrong. He said, "I just heard a funny story." And Neil said, "What's that?" He said, I heard that you bailed out of the LLTV an hour ago." He said, "Yeah, I did. I lost control and had to bail out of the darn thing." And the fellow that was Alan Bean, who was sort of talking to him about it, said he can't think of another person, let alone another astronaut, who would have just gone back to the office after ejecting a fraction of a second before being killed.
Yeah.
And that underlines the mettle of the man and why he was a perfect choice, and all of them were great choices for those extraordinarily dangerous missions, because you had to keep your wits about you. You had to be ready for any potential crisis, and we certainly saw that in Apollo 13.
Absolutely, yeah. It's a really nice insight when you see things like that. I assume that the test vehicle was totally destroyed.
Yeah, I think it blew up. I think it was in flames and it flipped over, and I don't think there was much left of it. But he walked away from that, and all he did was bite his tongue and
go back to the office.
Quite an amazing man, and that was 50 years ago this week. So, and aren't we glad he got out? Because what happened a bit over a year later, was just beyond anybody's comprehension, I think. Fred, as always, it's been a great pleasure. Thank you so much.
And a pleasure to talk to you too, Andrew. And thank you again, and we'll speak again soon.
I hope so. Fred Watson from the Australian Astronomical Observatory. And from me, Andrew Dunkley, thank you again for listening to Space Nuts. Tell your friends, share us on all your various social media platforms, Instagram, Facebook, Bookface, Twitter, and the rest. I don't know. And don't forget to keep in touch. Send us your questions. We love them. And we'll see you next time on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.